Before we jump into this idea of binary multiplication and doing bigger numbers, let's take a step back and look at multiplication in base 10. So if we had a problem like this, 14 times, how about 22? Multiply these two numbers together. Well, the first thing we do is, maybe you do this the other way around, but I do it like this. 14 times 2, that comes out to be 28. And then we have 14 times 20. But what we really do is we put a 0 here, right? We put a 0 and do 14 times 2 again, which is 28. So we just, for each place value, we shift it by 1 0. And then we go through, oops, that wasn't a very good line. We go through and add things together. So 8 and a 0. So these are called partial products. If we add the partial products, 8 and 0 is an 8. 2 and an 8 is a 0 with a carry of 1. And we've got 2 and a 1 is a 3. 308. So hopefully I did that right. So the key thing is this whole shifting by a shifting 1 0 or shifting one place value for each place, right? Adding a 0, padding it with a 0, right? I'm not sure what the real technical term for this process is, but we want to replicate it when we do binary multiplication. So in a way, binary multiplication is actually a little easier. The addition gets a little bit more taxing, but the multiplication part, the actual multiplication, is pretty easy because it's either all zeros or just the sequence again. For example, 1 1 0 0 times 1 is just 1 1 0 0. I'm going to do a different color for each row. So now we've got 1 1 0 0. So we're going to pad it with a 0. I'm gonna get super colorful here. It's gonna be crazy. I'm gonna pad it with a 0, and now we've got 1 1 0 0 times 0, which anything times 0 is just 0. So even though I padded it with a 0, it wasn't really that useful. But now the next one we're gonna pad with 2 zeros. And we've got 1 1 0 0 times 1. So that comes out to be, it comes out to be 1 1 0 0 padded with these 2 zeros. So we've got a 0 here, 1, and a 1. And this last part we're going to pad with 3 zeros. And it's 1 1 0 0 times 1. So what's that come out to be? Well, we've got 0 0 1 1. And that's what we get, right? So now we just need to go through and multiply this all out. Or sorry, not multiply. We've got a partial product. We need to go through and add things. So bunch of zeros added together, that's a 0. Bunch of zeros, that's a 0. 1 and a bunch of zeros, that's a 1. 1 and a bunch of zeros is a 1. 0 1 0, that's a 1. 2 ones added together, that's a 0 with a carry. Right, so I'll try my little carry there. And we got a 1 added to a 1, so that's a 0 with a carry. And then 1 added to a bunch of zeros. That's what we end up with. 1 0 0 1 1 1 0 0. Cool. So, a couple things to note here. The first thing to note is we have this 4-bit number being multiplied by another 4-bit number. And look at what we end up with. We end up with 8 bits. We doubled the amount of bits. And that we'll find that's actually true for every sequence. Is the max size we can have is 2 times the number of bits. That's the number of bits in our results. And so that's why frequently processors will actually split up the results of multipliers into the upper bits and the lower bits, or sometimes upper half, lower half. There's a couple ways: upper byte, lower byte, or in this specific case, it'd be upper nibble, and lower nibble. And then you might look at each one of these in parts, because we were assuming that our system is a 4-bit system, and now we generate an 8-bit number. So we need special stuff to handle this, and we can only look at 4 bits at a time in a way. The other thing to look at with this process is for 4 bits, for 4-bit multiplication, we generate 4 partial products. And that's something that we would have to store, right? We'd have to store these 4 numbers. And that's actually kind of a drag, right? Storing 4 numbers, that's a lot. I mean, I don't want to say it's a lot of hardware, but it could be a lot of hardware depending on your circumstances. And so sometimes what will happen is we'll have a running sum where this will go into some sort of register or memory device, and then this will get added into this register, and then this will get added in, and this will get added in. So it kind of happens, we do the addition as we go rather than one final step. So that's just something else to be aware of. But yeah, cool stuff.